This case study is about the shoreline erosion control project for Kuala Nerus Beach, Terengganu. The state of Terengganu is located in the Peninsula of Malaysia on the east coast. This map here shows the Terengganu states and the river basins. We see over here the stretch of beach from Kuala Merang to the airport is Pantai Kuala Nerus or Kuala Nerus Beach. It is a relatively straight, sandy beach area and highly sloping towards the sea. It faces the South China Sea and is always exposed to strong waves, especially in the months of November to March. Back in year 2015, during the National Coastal Erosion Study, coastal erosion along Kuala Nerus Beach has been reported to range between 2 meter to 11 meter per year. In year 2016 and 2017, it has accelerated to 20 meter per year, and with a number of locations reported to experience serious erosion. In year 2020, Pegunungan Maras has been reported to experience severe shoreline retreat due to high wave and wind event. In this slide, we see the photos of coastal erosion in Pengamang Teleport in year 2016 and also in Pengamang Telong in year 2017. The picture below here shows what happened to Pengamang Telong before and after the erosion event. What we can see here is a blue hut, and after the erosion, that's where the SIM hut is located. So we can see how serious the condition is. The pictures on this slide show the serious erosion that happens in year 2020 in Mengamang, Pangkalan Maras. So we can see the condition after the attack of the strong wind and wave condition. Kuala Nerus has also experienced flooding in some of these past events, which was recorded and reported in the headlines of local news. The main objectives of the project are to carry out the coastal hydrodynamic and littoral process study, and second, to propose coastal protection works to overcome the erosion problems at the shoreline along Kuala Nerus Beach. Right now, let's take a look at some of the historical satellite imagery taken from Google Earth. What we are seeing here on the top is in year 2006, where we have the Terengganu River mouth over here, and also this is where the location of the Terengganu airport is. By year 2011, we noticed that there has been changes where there is a pair of breakwater constructed in the Terengganu River mouth, and the airport runway has been extended into the sea with a headland, artificial headland, as can be observed here. Since the extension of the airport runway into the sea, there has been some changes, as we can see here from year 2011 to 2013, where the shoreline towards the north of the airport has undergone erosion or retreat. Subsequent to the erosion detected, engineering work has been carried out to protect this part of the shoreline, where we can see here some detached offshore breakwater has been constructed by year 2017, and also there is a groin here to contain the sand which has been replenished in this part of the coastline. There is a small river mouth just to the left of this groin over here. However, within a few years, by 2019, as we can see here, more detached breakwater has been constructed further north because of the severe erosion that now propagates towards this side. So essentially, what happened is that due to the construction of the airport runway, the erosion has happened to this part of the shoreline first, and subsequently, after this part is protected, the problem migrated northwards. After the second batch of the breakwater was constructed, the erosion problem migrated further north. We noticed that this part, the condition in 2019 has evolved by year 2022 to show severe erosion has taken place. This is the location of Mengamang Teleport. Zooming out again, if we look at the whole area, the airport is located here, and this is the Terengganu River mouth. Terengganu River is a big river system. As you can see here, this is the Terengganu main river. This is the large basin which drains through this single outlet, which means that it carries a lot of sediment from the basin into the coastal area. When the sediment reaches the near coast area, it will be carried by the coastal current along the shoreline, so that it becomes a source to replenish any soil loss that might occur along this relatively straight shoreline. However, due to the construction of this pair of breakwater out into the sea, the consequence is that the sediment that is discharged through the river mouth exit into the offshore area and is not able to replenish any soil loss in this part of the coastal area. And furthermore, with the construction of this artificial headland of the runway extension, the result is that there's no longer any significant supply of sediment to Kuala Nerus area, and as a result, the wave is able to erode and carry away sediment from these locations. Despite the protection work has been carried out, the problem continues to migrate to the north because there is a lot of hydraulic power for the wave energy to carry the sediment away from this area, and there's no replenishment. This figure here summarizes the root cause of the erosion problem in this region north of the airport, where the soil loss was found to create a net accretion zone over here near to Kuala Merang. This is Kuala Merang, and the reason for the transport of the sediment in this direction is because of the net littoral drift direction in this part of the shoreline. This figure here shows the eroded area, and also based on survey carried out along the shoreline, it has been identified the losses caused by the erosion to the property owners, including resort owners, businesses, and even fishmongers, has increased over the years and is significant. This figure here shows the typical methodology of coastal investigation. So first and foremost, we are going to need the related data to carry out modeling of the coastal hydrodynamic, the wave condition, and the littoral transport in order to evaluate the different options to mitigate the problem before we come up with the detailed design. And also, since the shoreline would also have river discharge, so we will need hydrological data so that we can carry out basin rainfall runoff modeling and soil loss modeling, so that we can find out how much is the discharge and sediment discharge into the area. And this also will be taken into consideration in our environmental assessment and in the preparation of the environmental management plan of any foreseen problem. For the river, we will also be carrying out hydraulic modeling using cross-section and tidal data as the downstream boundary condition. And all this will give us the detailed design, and so that we are able to have an initial costing of how much the mitigation work might be. On top of the hydraulic and hydrological modeling, for the environmental part, there's also a detailed methodology which will not be discussed here. For any new projects, the team usually will first carry out a site visit so that they are able to familiarize with the condition on the ground and the study area. This is Tok Chumbao near the second mitigation works, where a pair of 100-meter long detached breakwater has been constructed, and there are also revetment constructed along the shoreline in between the pair of breakwater. We see this Tongpolo structure over here connecting the shoreline to the breakwater. This is the Tongpolo viewing with the shoreline on this side and the breakwater on this side. Despite the revetment over here, we can see that during the site visit, this part of the shoreline still has very clear evidence of erosion. As a result of that, we can see this steep or cut or scarp due to wave action. This is the area where a serious erosion has taken place. There's a coastal road over here. However, because of the erosion, we can see that part of the road already collapsed, and as a result, some of the temporary revetment has been constructed, and even beach nourishment is in process. However, this is only a short-term solution. A long-term solution for this area, Pangkamas, is required. These are some of the data required for the study, which has been listed out. For example, bathymetry data, rainfall, streetflow, water level data, river cross-section data, flood records, current data, and then water quality data and other geospatial data, the seasonal wind data, and also soil investigation are required. Unlike Kuala Terengganu, where the Sungai Terengganu is a large river basin, along Kuala Nerus, the streams are all small streams, and the basins are all small coastal basins that discharge directly into the sea, which is why the cumulative flow rate are all very small, and as a result of that, the sea action is able to build up a high beach berm that further prevent the rivers from discharging properly into the coastal area. There's only one nearest water level station in this part of the study area. This figure here shows the demarcation of the coastal river basin based on SRTM data. However, due to land clearing for agriculture purpose, there is also a change of the flow correction from region which is outside of the original basin into this canal which discharge through Kok Tuan Nit River mouth. This example of the coastal basin, after taking into consideration the drainage network system. So the largest one is this Kok Tuan Nit, which beside this natural basin, it also collects water from part of this agriculture area. And then we have a few other smaller basins along the shoreline from the airport here to Kuala Merang over here. This slide here shows the list of all the small river mouths in between the airport to the south over here and all the way to Kuala Merang to the north over here. So these are all the small river mouth, and the catchment are all typically very small. The 10-year ARI is also very small. Notice that Sungai Gomtoni is one of the largest already. Kuala Merang is outside of the study area, and Kuala Terengganu is towards the southwest, not listed over here. So from number 2 to number 10 here are all the small river mouth in our study area. This figure here shows the land use of the study area and the land use zoning according to Plan Malaysia. One more thing to take note is that the area being a coastal front is relatively flat and low-lying. Bathymetric data is required for our study, and in this case, the previous study has collected the bathymetry from Kuala Terengganu all the way to Kuala Merang and further north. This example of the tidal datum available near Kuala Terengganu area. The Integrated Shoreline Management Plan study has carried out a survey of the coastal shoreline profile. So example here shows the nearshore profile in Kom Tuan Nit, okay, which is characterized by a very mild flat beach of only about 0.74% in the first kilometer. There's no distinct longshore bar within the nearshore area. The two plots here shows the average beach profile in the different parts of the beach, where in one of the chainage in kilometer 73, there is a Bukit Rakit, which is a rocky outcrop where it can be observed during low water level condition. The figure below here shows the average profile in the beachfront from kilometer 69 to 900, where we can see the white beach berm over here, the sand dune at the back, and this is the part where it slopes towards the sea, and that's where the water is. In Sungai Gomtuan Nit, the broad berm is much obvious, separating the sea from the discharge from Sungai Gomtuan Nit. This is the Met Ocean data showing the windrows for Kuala Terengganu. We can see here that the wind is mainly blowing from the northeast direction during the monsoon season from November to March. Other than that, in the month of April, May to September, and then October, the wind direction as shown in these windrows. Overall, for the entire year, the annual windrows from 1985 to 2019 is shown here, where the energy is coming mainly from the northeast and the east with wind speed above 5.5 up to almost 8 meters per second. Whereas during the other seasons, the wind is coming from the south or the southwest direction, but the magnitude is much lower, less than 3 meters per second. This shows the wave rows of the region. Again, over here we see the annual wave rows, where the wave energy is mainly coming from northeast direction or the southeast direction. And this is the wave rows for the month of January, February, March, and then all the way to October, November, and December. Wave statistic analysis classified the dominant wave into two categories. One is coming from this direction, and the other one is coming from this direction, with the significant wave height and wave period as shown here. For modeling, the coastal model will have to be calibrated for the water level, for the current magnitude, which is shown here, and also the current direction, which is shown here. This plot over here shows the maximum current in the area, where we can see that the current is much higher in this region near Batu Rakit, where there is this natural outcrop of rocks. Shown here is the tidal simulation for different condition during low water and during high water, during flood condition, and during ebb condition. This is the wave simulation for northeast monsoon. This is Kuala Merang, and this is the Kuala Terengganu River mouth. This is the simulation for southwest monsoon season. A simulation of the littoral transport shows a very interesting phenomena. We have Kuala Merang over here and airport over here. The distance is about 25 kilometers. The transport is limited in this part of the shoreline, which is already protected. But for the rest of the shoreline, we can see that there is a high gross transport. However, generally the transport is left going, the rate curve over here, which is more than 100,000 here, but the right going sediment is much less. So as a result, we have a net longshore transport to the left, which is towards Kuala Merang. To control the sediment loss, the shoreline erosion of our study area, two proposals has been suggested. Option one is to use a series of detached breakwater, like the one that has already been used near the north of the airport. So this detached breakwater will be built all the way from the current hotspot area to the north. Another option is to use groin field, which is constructed along the shoreline. This example of the groin field and this example of the detached breakwater. This figure here shows the shoreline evolution study if the option do nothing is adopted. So what we see here is the shoreline from year 2020 all the way to year 2040. If no mitigation work is carried out, we expect that there will be a significant shoreline retreat. This is where the Pangkalan Maras, where we see the half the road collapse just now. So obviously, there will be a very significant consequence if no protection work is carried out. The soil loss here, if we follow the scale, is way more than 100 meter. This is what can be expected if we adopt option one with a series of detached breakwater, how the shoreline may evolve. The result is obtained from numerical simulation to look at how the shoreline would change up to year 2040. If a series of groin is adopted, similarly, we expect that it will help to control the shoreline erosion. But one problem with the groin structure is that it will interfere with the longshore transport itself. For each of the options, the costing is also carried out. The engineers will find out where are the nearest source of quarry stone for the protection work and the unit rate of the different type of material. And then for the breakwater and also the groin, the total volume of the armor rock required, the geotextile and the gravel are estimated, and then the total amount of the uh, option is then calculated. Once the option is finalized, the consultants will produce the engineering drawing, which gives the locations of the breakwater to be constructed along the shoreline, and also the typical cross-section of the breakwater. In this case, the breakwater has been chosen as the options for implementation.